So in this video, we're going to discuss for just a few minutes about what is normal. What is mathematically normal? So whenever we're thinking about what is normal, we're going to consider absolute value. Absolute value is a mathematical concept that helps scientists and mathematicians understand and quantify a normal range. We do this a lot. And one of the things that's been a big discussion these days is what is in a normal range for someone's body temperature. So, an absolute value function can be used to show how much a value deviates from a perceived norm. Now think about what it means to deviate from a perceived norm. This is some good vocab for you. So if we think about our internal body temperature, and most people would agree that 98.6 degrees Fahrenheit is a perfect body temperature for us as human beings. However, that temperature can vary. Vary means the same thing as deviate. It can deviate or vary by as much as 0.5 degrees Fahrenheit and still be considered normal or within the normal range. So here is the number line, and here's optimal right here in the middle. So optimal at 98.6, but according to this information, it can vary or deviate 0.5 degrees to the right or to the left. Remember, everything on the number line to the right is getting bigger. Everything to the number line on the left is getting smaller. So, if 98.6 is perfect, but we can vary or deviate by up to 0.5 degrees, we can still be considered normal. So, let's think about that a little bit more, and let's look at some questions here. So, here's our number line up at the top. So what are some observations regarding this graph? Well, first of all, let's answer this question. What are some acceptable normal temperatures? So if the optimal temperature is 98.6, but yet we can deviate 0.5 in either direction, we can list some acceptable temps here. We could be 98.3. That's an acceptable temp. We could be 98.7. That's an acceptable temp. We could be 98.613. That's an acceptable temp. And if we're able to deviate all the way up to and including 0.5 above, we could even say 99.1. So all of those are acceptable normal temperatures because they do not deviate or vary 0.5 from the optimal temperature of 98.6. So what are some unacceptable? So what are some that are out of the normal range? Well, 98.0, that's out of the normal range. How about 76.3? That's clearly out of the normal range. What about 99.15? That's above 99.1, so it's out of the normal range. So that's what we're talking about when we ask what is normal. We're able to put it within a range. So how do we represent this, represent the graph mathematically or algebraically? Well, once again, here's what the graph looks like graphically. If we want to think about it mathematically or algebraically, we need to use an absolute value. So if our optimal temperature is 98.6, we can actually use absolute value in order to write. So let me put my incredibly technologically advanced folded flap over right there of my graph, and we'll continue using it. So think about it. If 98.6 is optimal, we're going to let T represent our temperature. So what that means is this. Our temperature minus 98.6 has to be less than or equal to 0.5. But remember, we can go to the left or to the right. That's why we're going to include absolute value. So our temperature, the absolute value of our temperature minus 98.6 must be less than or equal to 0.5. And we're not going to solve this right now. This particular inequality we're going to get to in Chapter 2, but this is the whole idea of an application for absolute value. So in our next video, we're actually going to solve some equations.